A University of Michigan team has looked to nature for a green way to split water molecules. As hydrogen production becomes an increasingly important foundation in the effort to transition to zero-carbon emission economies, a team from the University of Michigan has looked to plants to provide a way to make H2 cleanly and efficiently. H2 is expected to play a role in decarbonizing industry, transportation, and entire economies. As much as it has promise in reducing or eliminating carbon emissions from many of the most polluting sectors of the world, it will only prove sustainably successful if there are methods of green hydrogen production that can keep up with demand. There are already many ways to produce the fuel, but most are not nearly as clean as they need to be in order to achieve the decarbonization required to meet climate targets. Researchers from the University of Michigan say that they have found a cheaper and cleaner way of producing H2 by replicating the methods used by plants. Making H2 not only cleanly, but also affordably is among the primary challenges in the way of the mass rollout of the fuel as a form of clean energy. This new study aims to provide a solution that will overcome those challenges and make H2 a practical and green energy source. The researchers are developing artificial photosynthesis as a clean method of hydrogen production. Artificial photosynthesis is not a new concept. However, the experiment conducted by this research team has provided a considerable improvement to the efficiency of the process. In fact, the efficiency level of the experiment showed greater efficiency than natural photosynthesis used by plants in nature. The process has to do with the use of semiconductor catalysts. It requires heat to speed up the process and to prevent the oxygen and hydrogen from bonding once again after they have been split apart from a water molecule. However, the necessary heat had proven too great for current semiconductors to be able to handle. As a result, the team came up with a new solution by shrinking the semiconductor. We reduced the size of the semiconductor by more than 100 times compared to some semiconductors only working at low light intensity, explained University of Michigan Computer and Electrical Engineering Research Fellow Peng Zhu, lead author of the study. Additionally, this method of hydrogen production uses self-healing semiconductor tech. It was tested using a light source with an intensity 160 times greater than the sun as experienced from Earth. The light was used to heat the water and split the molecules, resulting in substantial improvements to hydrogen production efficiency. I'm Jake Martin. Thank you for joining me today. Don't miss our awesome new ebook. Make sure to hit subscribe and grab it now on the link below. Leave us a comment and be heard.